All righty, let's go ahead and get this thing rolling. Yeah, today what I want to talk about is being productive by default, kind of architectures that actually make a difference in the way that your teams operate and perform. So what I'm going to talk about is ways that we can change our architecture to make ourselves more productive by default, and not just ourselves, but our teams and our companies. So let's dive right in. So the first thing is, let's just set some expectations. As a company, your primary goal is going to be to ship value to customers quickly. That is at the bottom of everything. If you don't get valuable things to your customers don't have anything to pay you for, and your company goes away. You no longer have a job. So that's got to be at the bottom of everything. We need to deliver value quickly so that people have things that they're excited about, that they like to use, and that they're willing to pay for. So that being established as the bottom line here, I don't think any team would disagree with that. No team is sitting around going, you know what, I really wish I didn't have to write any code. Like I think all of us in our hearts wish that we could sit around and do nothing and just continue to get paid. But I don't think we really want that. I think that, it feels good to ship. It feels good to have something get out into the world. So what stops us? What stops teams from getting things out into the world? Because every company I've ever been a part of will hit some patch where we're like, yeah, we're just trying to get this thing over the finish line and we just can't get it there. We're having a hard time shipping. So what I'm going to argue is that a large part of this actually comes down to infrastructure and processes. If you have infrastructure and processes that are frustrating, people will procrastinate working on them. If you have infrastructure and processes that are fragile, your teams will spend more time fixing them than they will shipping. And if you have infrastructure and processes that are slow, you're breaking people's flow. You're pulling them out of their operational context. And by the time whatever it is that they're waiting for finishes, they've moved on and now they've got to get back into that context. And so you burn a lot of cycles. So frustrating, fragile, and slow. And you may have seen this used before. Like if you've watched your team talking about the build, you may have seen them mentioning frustrating, fragile, and slow in discussion of your build system. So what I'm going to argue is that complexity is a code smell. I think that when you start building systems, one of the default things that's going to happen is it's going to start getting more complex. And that's inevitable. You can't avoid complexity entirely. Nothing sufficiently advanced can stay simple, right? But what you can do is you can control the way that complexity enters your system without thinking about it. The joke is that not even the joke, just the law is that the universe tends toward entropy. And if you let a system sit and just evolve naturally, chaos emerges. You find kludges and patches and people copy pasting one thing and reaching into the internals of this other thing. And now you've got this big spaghetti mess where everything's connected to everything and you can't make changes in one system without all the other systems needing a small adjustment. That kind of complexity is what I'm talking about when I say that complexity is a code smell. We as developers need to be working very diligently to make sure that we don't introduce that kind of complexity. Because when you have a complex system, it slows down developers. If every time that I make a change, I need to have the entire 10 to 100,000 lines of code of the code base in my head to avoid making unintentional mistakes, that's going to make me so much slower than if I can just focus on the file or few files that I'm dealing with. Complex systems slow down teams. If a system is very complex, somebody who has less context is going to need help from other people who have more experience. That means that more people get required from the team to do simpler tasks just because of the complexity of the code base. And that also means that one person is no longer really able to do the job. You need two and sometimes three to get pulled together and really dig into it and pair. And complex systems slow down companies. I mean, there's the initial problem of just if individuals are slower and teams are slower, the company is slower. But there's also this problem that happens where with sufficiently complex systems, teams start to get ownership over those systems. And then because they're complex, you can't really work on your system without touching somebody else's system, which now means that teams have to work cross-functionally. And anytime that you have to work cross-functionally, you're going to get some bureaucratic slowdown, not because it's bad to work with other teams, but just because the more people you add to a system, the more slowly it needs to move in order for everybody to have the necessary context to make decisions. So all of those things kind of snowball into extra slowness in a company. And it turns into, it's a mess at the individual level, at the team level, at the company level. All of that is really, really frustrating. So that snowball of slowness, or what I'll call the slow ball for shorthand, is a big problem. And if you've ever worked at a large company, I imagine you know exactly what I'm talking about. But if you're working at a small company, if you joined a company when it was 1, 2, 3 people, and now you're getting up around 15, 25, you're probably starting to feel this, right? And that's because incidental complexity, this accidental entropy that happens as systems grow and mature, if we're not careful about that, it will always show up. Even when you get to the point where you like they call them what, two pizza teams is the like software thing. As soon as you grow beyond that, you now have a relay, right? And that complexity is really hard to manage if you're not being thoughtful about it. So what I'm here to argue today is that there are architectural solutions that you can put in place that will melt the slow ball. And the architectural solution that I am most fond of, after having tried a lot of them, is what's called the JAMSTAck. And the reason for that is that the JAMSTAck is not very opinionated on how you write code. It does not care if you write using React or Angular or Vue or plain JavaScript or Ruby. It doesn't matter. What matters is that you thoughtfully arrange the components of your system in a way that intentionally increases simplicity as much as possible. So in the Jamstack architecture, what you're talking about is that the front end is decoupled. And that means that you can independently deploy the front end of your system. So it can still work with lots of back-end systems, but when you build and work on and deploy the front end, it shouldn't need to touch any of your back-end systems. That's an important distinction to make, because if you've ever worked on a team where when you go to deploy the front end, you have to also go to the back-end team and run all of their tests that you don't understand. And then you have to go to the DevOps team and ask them to do everything. And then it has to go to a staging branch where it'll get QA'd. And then it goes to like the next branch where it'll sit for 2 weeks for whatever reason. And then the team finally takes it live, and it takes you 2.5 to 4 weeks to ship anything to production. That is not a very agile way. That's not a very fast way. It's not a very productive way to get things to the internet. If instead you've thoughtfully decoupled that front end and you've kept those systems through a clear API boundary separate from each other, then when you go to deploy your front end, you can be absolutely confident that it will not affect anything outside of your front end code base. And that means you don't need quite so many checks. And in teams that have implemented this well, they don't have any checks. They run an automated test suite. They do a deploy preview where they have human verification. So a teammate will look at the changes and make sure that the changes are good. And once they get that PR approval and the automated test pass, they merge it and it goes live. So you're talking about 20 minutes to a fix on something quick, right? That is a game changer when you're talking about working quickly, because I can have an idea and see it in production today. That is extremely motivating versus, well, I have an idea. I'm not sure if it's going to make it through all the 4 layers of approvals that it needs to go to. And I also don't know if it's going to break anything in these other systems that I never touch and I don't know. So that's a big, big benefit, is that decoupling. The front end is also compiled. Another huge goal of the Jamstack is, whenever possible, pre-compile things. So instead of having some data that almost never changes get queried on every page load, query it once at build time and then compile those assets so that, if possible, all you're shipping to the browser is HTML and CSS. There are some really good frameworks for this. If you look at virtually anything out there, in Angular, there's one called Scully that does this. In React, there is Gatsby, there's Next, there's several React Static. In Vue, there's Nuxt and Gridsome. And then in the non-framework world, or I guess there's also Svelte Kit, which is very good at this. And then there are non-framework or framework agnostic versions like Astro. And Astro is especially interesting because you can use whatever you want. You can put Vue or Svelte or Solid or web components or whatever into it, and they all compile down, if they're not interactive, into plain HTML and CSS. If you build an Astro site and ship it and it doesn't have interactivity on that page, you'll ship 0.js. And that is a very good thing for a lot of reasons. The reason that compilation is exciting is that if I don't have any moving parts on my site, I can be 100% sure that it doesn't break when I ship it. So the fewer moving parts we have, the fewer dependencies we have. If I don't have to query the database because I hit it once at build time and I've got that data cached, then I don't have to worry about whether or not my database can handle heavy traffic loads. I only have to put my compiled assets onto a CDN, and now I have all of my my site is basically DDoS proof, because a CDN is about the last thing that's going to go down in a DDoS attack. And if you've eliminated the other things to only being necessary at build time, then none of them need to be scalable, and you don't have to worry about hugely expensive server bills to scale them around the world. And the last part, which I've already touched on, is that the JAMSTACK is deployed to the cloud. In order to get the most out of this, like, you don't have to. You could put this in a server under your CEO's desk and like it would be fine. But if you deploy it to a CDN, you honestly probably will pay almost nothing to host and run your entire front end. Because if it's decoupled and compiled, you can put the whole thing on. I work at Netlify. You can put it on Netlify for free. You can put it on AWS's CDN, which I'm blanking the name of right now, CloudFront, for virtually nothing. You can put it on GCP or Azure or any of them. They've all got some kind of a distributed CDN, and they're all cheap or free, depending on which service you're using. So this is a great way for front-end teams to reduce risk. You know, it decoupled, pre-compiled, deployed to the cloud. You've reduced risk, you've reduced turnaround time, you've increased velocity, and you've dropped your costs to almost nothing, which means that the risk associated with deploying is borderline nothing, right? And if you're using a system like Netlify, or you've got a system implemented similar to it on your preferred CDN, then you have instant rollback. So if you do have a commit go through that's bad, you don't get paged at 4 a.m. to go fix some code. You get paged, you click the button, it's fixed, you go right back to sleep, right? So there's a lot of safety built into this pre-compiled world. So decoupled front ends reduce complexity for all the reasons that I talked about. They pre-compiled front ends reduce fragility. Like I said, if there's no back-end system that needs to be hit, then you don't have to keep those systems up. There are fewer things to break, fewer links in the chain. And then we can talk about serverless functions, because serverless functions are a way to add some of that server-like functionality into web apps without having to fully adopt a server. And the reason that I bring this up is that a lot of times when you start talking about this JAMSTACK architecture, we're going to decouple the front end, we're going to pre-compile everything. Okay, but I have this one thing that I need to do. I need to submit a form and put that person onto our contact list, and that requires an API key for whatever service we're using. Okay, well, you can't put that in the front end, right? You can't make that client-side JavaScript. And so does that mean that I need to stand up a server so that I can take one endpoint that will accept this form submission just so that I can hide this key? I mean, you could do it that way. And if you've already got server infrastructure set up, sure, whatever. But if you're using serverless functions, serverless functions are a way to kind of bundle that up. If you're using a service like Netlify, there are a few others that do this. You can actually put your serverless functions right alongside your front-end code and use environment variables to hide the keys. And then those serverless functions will automatically deploy. And so for that one piece of back-end functionality that you get, you can write a node function that takes the event, pulls out that submission, grabs your environment variables to get the key, and then sends that off to your subscription system, and then sends back a like, hey, we got your submission response to the front end, right? And now that serverless function, because it's going to be deployed to AWS Lambda or one of the other big cloud services, it scales, it's up, it's gonna run. You don't have to worry about like heavy load because serverless auto scales. And now instead of having to build this whole thing, what you had to do was write just the function, just that little bit of logic that you needed with a tiny wrapper for a handler. And that's it. You've deployed it, it's done. And if you're using a service like Netlify, then you don't even have to write like the gateways or the proxies or anything. It's automatically configured. And like I said, it's not just Netlify. There are other services that'll do this. And that is such a superpower for front-end developers, because for me, what I get worried about with servers is not the little bit of logic. I can write API endpoints all day. What I get nervous about is I don't want to have to configure Nginx. I don't want to configure firewalls. I don't want to worry about like traffic rules. I don't want to worry about all these little underlying DevOps and scalability and security concerns that are just not my area of expertise. So when I use serverless, all of that stuff, the ops, the security, the firewalls, the lockdowns, all the things that need to happen for the infrastructure, those are managed. And that's the magic of managed infrastructure, is I get to write logic for my app. I deploy it alongside my app in source control, and the rest of it, just works according to industry best practices in a way that, we know it's better than what we would do ourselves because we're not experts in that particular field. And Amazon or whatever cloud provider has a vested interest in making sure their infrastructure is secure. So they're going to spend a lot of money to hire the best of the best in the field to make sure that those defaults that you're deploying to are absolutely bulletproof, right? So it's just it's a great way to do more, feel like you have superpowers as a front-end dev because you can write back-end logic without having to learn a whole new discipline. And the thing that is really magical about this is, like, you don't have to think about servers. You don't have to think about DevOps. You don't have to think about rollbacks because there's a button for that. You don't have to think about scaling because it's automatic. You're on a CDN, you're using AWS Lambda. Those things both auto scale. You don't have to do anything. And you don't have to think about caching. Caching is already managed by a CDN. And so you should never really have to think about it because, again, precompiled assets, those don't need complicated caching policies. You don't need to relay a cache from the API layer of the cache to the intermediate UI layer of the cache to the final delivered UI. And honestly, when people talk about caching being hard, it's because they're trying to do these multi-directional caching swaps and stacks. If you just have one layer to cache, caching is actually pretty straightforward. It's the problem comes in when you start to make it complicated, right? Again, complexity is the root of all slowness. And the best thing about this is that if you start to adopt this architecture, you've decoupled your front end, you're precompiling everything whenever possible, you're shipping to a CDN. If you've got some backend logic, you're throwing it up as a serverless function. All you have to think about now, because all of those other concerns have been automated away, is shipping. And this is a really, really powerful concept because now you don't need layers and layers of extra checks and QA and all of these other things. You can strongly automate the vast majority of your checks, including like visual diffs. Have something like Applitools run a visual diff against your code every time you push a deploy preview up and check if you made any inadvertent changes. And if you did, somebody has to go and manually approve, like, yes, I meant to make this visual change, or no, we didn't mean to make that visual change. And you can't deploy unless somebody has like confirmed that it was intentional. You can make all this stuff work in a way that doesn't require multiple layers of teams and multiple layers of checks. And that means that you can get to some really powerful workflows. This is a random day in the Netlify production code base, right? This is our main app. This is the core of our business. It's where all of our money comes from. And this is the main branch. And you can see here that in the span of 3, 4 hours, 5 hours maybe, we deployed to production 4 times. Each of those deployments took around 8 to 10 minutes. And those pushes, that was as soon as somebody merged their PR. And the way that we merge PRs at Netlify is that somebody is able to post up a PR, it automatically generates a deploy preview. Somebody else on the team, on the front end team, will review that PR, leave code comments if necessary. And while they're doing that, the PR is having all the automated checks run against it. So we've got Cypress checks, we've got some unit tests, various other checks to make sure that things work the way that we expect them to work. And once those checks turn green, and once the PR gets reviewed by a team member and approved, they merge and it goes live within 10 minutes. And this is, May 7th was a Friday. right? So we in 5 hours on a Friday, we merged to production 5 times, 4 times. Like, this is an incredible workflow. I, coming from the other companies that I've been at, this is really, really unique to this particular architecture. And it's also really powerful what this does for people's sense of autonomy and their sense of ownership. When you ask one of our front enders if something is wrong, they don't try to figure out who else could be to blame. They open a PR and it's fixed within 20 minutes. Like, it's outstanding how quick our response time is. And this means that we almost never have pager duty. And when we do have pager duty, somebody would just go back and click on one of these PRs, and that would be it. They would have rolled it back, and they'll fix it tomorrow when they're on shift, right? That's okay. We do that all the time. It's a very powerful workflow that I think is really critical to the sense of ownership and velocity that we have at Netlify on the front end team. So this is maybe the biggest thing. We all want a culture of shipping, right? We all want our companies to ship fast, to work fast, to be fast. But in order to do that, we have to have architecture to support it. If our architecture blocks us from doing things quickly, from being able to ship, then we can't expect our teams to just imagine that's not there and still be fast anyways. We have to have fast architecture if we want fast shipping, right? That's what I got today. So thank you so much for watching. And if you have any questions, make sure you throw those into the Q&A channel, right?
Let's see. I'm not seeing any questions right now. Although I may be in the wrong channel. No, should be good. Yeah, I'm not seeing any questions right now, but I think that was pretty awesome. It's something that I've started doing as well. As you were saying with caching, you really don't have to think about that stuff. I remember a few years ago when we were working with a couple of backend teams as well, and they were all using, the name of the software is now escaped my mind because I'm not working with backend very much anymore. But everyone was basically using specific caching tools for all of the authentication and keys like that. And honestly, it's way, way, way too complicated. It really doesn't have to be that complicated.
Yeah, you know, I've done a lot of consulting for really large enterprise teams, and almost every time they tell me a horror story about how they spent 4 days, you know, they deployed on Thursday, their site was down from Thursday night until Sunday morning because they had some weird caching issue where they'd cached an API and then they'd cache a partially rendered page, and then they were trying to cache the final result. And when they would clear the cache, the result of one part of the cache would repopulate the cleared cache. So they'd get these half states, and then things would be broken and out of sync. And yeah, every time I see a team starting to design a very clever caching mechanism, I just bring up this story about when I worked at IBM. So when I was at IBM, everybody there had very clever caching strategies. We had Redis at one layer, and then we had, you know, this varnish cache at the edge, and we did all these things to make sure that our caching was just really, really good. Nobody understood how it worked. So everybody would append random number query strings to the end of every asset file to guarantee that it would never get caught by caching. So basically, by building this really, really clever and really, really effective caching strategy, we confused our front end engineers enough that they cost us probably thousands or hundreds of thousands of dollars because they refused to use the caching layer at all. And we were serving completely uncached requests just about every time because we made it too hard. We made it too complicated.
Yeah. Well, I mean, it seems like a good idea until it's not, right? Varnish and Redis were the names that I was thinking of that I couldn't remember.
So I just saw a question come in. Are you doing all these statically generated doing all this statically generated content for authenticated, but perhaps not personalized content? Sometimes it really depends on the way that the page is set up. So if what you're doing is you're showing somebody like a dashboard where everything on the dashboard is their own data, what I would probably pre-render is all of the shared stuff. So if there are, say, notifications from the company and like a news feed or anything that's kind of relevant to all users, I would pre-render that. I would pre-render the markup that contained all of the different reports and things on the dashboard. But then I would use a client-side call to pull in that dashboard. And if I needed a key, I would make a client-side call to a serverless function. And that would be the way that I would actually pull in that personalized data. But we do have the concept if you are comfortable with writing headers, you can do redirects based on the presence of a cookie. So you can check whether or not somebody's authenticated and like redirect them away from a page. So you can like pre-render authenticated stuff. I wouldn't, just because if you get any number of users, it becomes extremely complex to do so. But this is it's you. That's why it's not like pre-compile no matter what. It's always pre-compile when possible, like when it makes sense, and that's sort of where we land on it is if you can do it. If not, that's fine. You don't have to, but it's it's ideal for reduced complexity to not have to keep that like account system up and running and scaled to your millions of users.
I think with I was just thinking to myself, how could we make this easier? And I was thinking maybe with micro front ends or like pre-rendered components per page would be a little bit easier to actually do an authenticated page without customized information. But even then, it still seems way too overcomplicated for something that can be solved in a much simpler fashion.
Yeah, I mean, it typically speaking, like if you start talking about dashboards, I'm usually going to recommend go SPA. Like at that point in time, you're no longer doing, you're not getting any of like the benefits of pre-rendering, because like only one person is going to load that thing. So when they load it, and then the next time they load it, the data is going to change. So okay, so now what, you're going SSR, you're going to run a whole server for this page? No, don't bother with that. Just, don't overcomplicate your architecture. Just put it up, use a serverless function to get the data if it needs to be secured the way that you get it, and like just be done with it. Like it's all good. Write accessible code and focus on accessibility, not on cleverness.
The reason I'm laughing actually is because we attempted to do exactly that on an internal project. We were thinking, this isn't working with the authentication, let's change to SSR. And 3 weeks later, we realized, let's just turn SSR off and actually get it working.
Yeah, I mean, like, look, I think SSR has a place. There are use cases for SSR, but most of them are, it just doesn't, it introduces a whole lot of problems. So you need to have a whole lot of problems that you're trying to solve before standing up SSR is worth it, in my opinion.
Oh, for sure. I completely agree with that. Completely. And from experience now. Just want to check if there's any more questions for you guys. For everyone, for everyone here, because we might need to move on to Dave's talk now, if there are no other questions.
Yeah, and if anybody wants to,
wait, there are questions.
Oh,
sorry,
we got more?
I missed. Yeah, we actually have some in the Slack channel. So, one question is, even while being decoupled, you have some sort of dependency. Think of new deprecated API endpoints. How would you handle that when using the JAMSTAck architecture?
So the way that we've handled that is because, at Netlify, for example, our dashboard is a JAMSTAck app. That front end's completely decoupled. And the whole Netlify app runs as a collection of APIs. We're always working on those APIs. Some of them are internal. That means that they change. And what we found is when everything was monolithic, what would happen is we would have our front end, and our front end would sometimes use APIs, and sometimes it would use helper functions that were buried somewhere in the back end. And when we went to change things, the API would change, but that helper function wouldn't. And so we would keep using the helper function, even though the API was no longer exposing that thing. And so then you have this confusion where the backend team thinks that nobody's using that thing anymore because the API deprecated, but there's still some like old code hanging out in the backend code base that the front end is reaching in and grabbing. With decoupling the front end, what happens is you get one very strict contract. You have an API. You can either call that API or you can't. And that means that when the backend team wants to change or deprecate an API, they know exactly how to communicate this. They open up the PR that's going to deprecate the API, and then they can hit all the teams in the company and say, hey, this API is changing. You've got this many days to update or it's going to break, right? And all the teams know if we make this API change, it will all be fine. And, and that also encourages like, can we make it not break? Like, is there a way to keep backward compatibility here and just throw a warning so that teams fix it on the next time they're in that section of the code base? sometimes yes, sometimes no. But what I like is that it leads to an easier communication channel, because now we all know what the contract is. It's not that we've all touched different parts of the same code base. It's that we have a very clear API contract. I'm going to send requests to this endpoint. Did anything with this endpoint change? Great, you need to call me. Right?
Yeah.
And that tends to be it's a more tractable problem than like, hey, we're all in the same million line spaghetti code base. Everybody be careful in here. You know what I mean?
Yeah, that makes sense. So we actually have a few more questions. If you don't mind me just
Sure.
shooting a few at you. So there's one question here, but I feel like there are probably two questions. Sorry, there are two questions here, and I feel like it's probably one question. That makes more sense. So the first question is, how would you get started with moving towards the Jamstack from a more traditional approach? And the second question, which I feel like probably fits in here as well, is what are some good resources to get more in-depth knowledge or understanding on the Jamstack?
Mm-hmm. Okay, so the first thing that's important to keep in mind is that this does not have to be a full refactor. You don't have to boil your whole app. What I would look at is the next time that you're looking to build a new UI piece, if you've got a section of your site, or if you're going to refactor a certain page, lift just that piece out, and then you can do what's called a reverse proxy, where let's say we're going to, like we did this at IBM, for example, we wanted to refactor this page to be as close to Jamstack as we could get on IBM's infrastructure. So we took our account section of the IBM Cloud app and we just built a new app. And that app was a front end that only had a /account route. We built it as a Jamstack app. And then when we put it into our front end, we just reverse proxied. So any request to /account hit this new app, which was completely separately hosted, right? And over time, we added more and more of the UI into this approach. And because it's IBM, we didn't actually want to get a monolithic front end. So each team had their own reverse proxied section of the front end. And this is a really nice incremental adoption strategy, because some of the teams didn't want to use the Jamstack. They decided they were going to keep using an Express server and they wanted to build it all themselves. And so they did. And then they reverse proxied their endpoint in. We would build ours with this Jamstack approach, and we reverse proxied like 3 or 4 of them in. And no one ever knew from the IBM Cloud site, because they just went to ibmcloud.com/account and they would see our front end. So that incremental adoption flow, and this is like, if you're using a tool that has built-in redirects, like Netlify has like a pretty straightforward syntax for this. It's a one-liner. It's so painless to do this. If you're using something like Nginx, it's still not painful, but it's less painless. But you can absolutely do it, and it's a really, really nice way to incrementally adopt. If you're looking for good resources to get started, there's a huge collection at jamstack.org. Jamstack.org is a really, really powerful, it's a good resource. It has a good overview. It's got a link to a ton of stuff. There are meetups there if you want to go and listen to people talk about this stuff. Probably there's a meetup in your area. I think a lot of folks sit here Amsterdam, right? So I believe there's a Jamstack Amsterdam meetup. I'd love to see y'all there. And then there is also, I have enterprisejamstack.com has a collection of articles. That's a product I'm working on that someday will be done. And then we write a ton about this at Netlify. I mean, I work at Netlify. I would love it if you became Netlify customers. So take everything I'm saying with a grain of salt, but we spend a lot of time trying to educate. And we hope that the education it's going to help you whether or not you use Netlify, right? We think that we've got an approach that really works well, but we're really just interested in people using this approach because we think it's truly better.